A very good morning to all the students. Today I'll be discussing in connection with lathe machine and operations. So in that we are going to discuss in detail about the significance, means importance of lathe operations, and what are the different types of lathe operations being carried out on a lathe machine. So before I proceed with today's presentation, just I wanted to revise what we have discussed in the previous session. So in the previous session we have discussed about lathe accessories. In continuation with that, we have discussed so many types of lathe accessories starting from the lathe centers, and in the last session we have discussed about the face plates, mandrels, angle plates, driving plates and the rests, with their sketches and with their applications in brief about the same, how these will support to carry out the different lathe machine operations. So now today we are discussing in detail in connection with the lathe machine operations. A lathe is a machine which helps to shape the desired shapes. Of course, the same one it is. The lathe is basically the mother of machine tools, which is used to give a particular shape by using the cutting tools. It is a mechanical machine that the workpiece is rotated against a suitable cutting tool for producing cylindrical forms. So this is very important. We always hold or we require to machine the cylindrical types of jobs on a lathe machine, and we require to hold and rotate in a particular type of an accessory like chucks, centers, etc., which is made of metal, or even it can be used for the wood also. Formation of wood cutting can also be done on a lathe machine, or any other machinable material. If any other machinable material is there, even that can also be machined on a lathe machine. Lathe machine is a machine that rotates the workpiece on an axis. This is important. Always, if you see the basic working principle of a lathe machine, you are going to see that the cylindrical jobs are made to rotate about their axis and the various shapes can be given like facing, turning, knurling and more, which we are going to discuss. So these are the different types of operations which are mentioned, like facing, turning, knurling and more in detail in the subsequent slides. The working of the lathe machine changes with every operation and cut desired. This is also a very important point to be noted here. Whatever the depth of cut is there, whatever the cutting speed is there, whatever the feed rate is there, everything has to be standardized one depending upon the type of lathe machine operation to be carried out on a given workpiece. Before starting the lathe operation, you must know about the feed, speed and depth of cut. These are the terms which are very, very important. What is the meaning of a feed? What is the meaning of a speed? What is the meaning of a depth of cut? And how different types of single point cutting tool can be used even on a lathe machine. So we are going to discuss in detail in the coming sessions in connection with the definition of a feed, speed and depth of cut. But in brief, we shall also have a discussion when we discuss about the different operations being carried out on a lathe machine. Each lathe operation has its own factors that need to be considered before doing the work. This is very, very important, because whenever, depending upon the type of operation, it is necessary to know which are the factors that affect that particular operation. So for that purpose, we must have a detailed knowledge about the machining operations and the terms and conditions in connection with how best that particular operation can be carried out. So in today's session, we are going to discuss in detail now again types of lathe operations, in that the lathe operation is basically used for the purpose of turning. So as the name itself indicates, turning means what? The workpiece is made to turn about its axis and to reduce its diameter or to reduce its length or to give some slots or to give some taper, etc. These are all coming under what? Turning only. So in that turning, the first one is a step turning. second type is a taper turning, and third one is a chamfer turning. So there are three types of turning operation. Okay, in that the first one is a step turning, second one taper turning, third one is a chamfer turning. Again we are discussing in detail. And the fourth one is contour turning, CONTOUR. So there are four types of turning operations which are being carried out on a lathe machine. And the second important operation is called as a facing, third one is grooving, fourth is parting or parting off, fifth is threading or thread cutting, sixth is knurling, seventh is drilling, eighth is reaming, ninth is boring, and the 10th one is a tapping. So there are nearly 10 major operations. So but in that we have divided turning into four types depending upon the type of formation, because the basic operation is a turning only. So now let us go in detail what is the meaning of a turning. Turning is the most common lathe machining operation. Just I have told, it is the most commonly used type of lathe operation. During the turning process, a cutting tool removes material from the outer diameter of a rotating workpiece. The main purpose of a turning is to remove the excess material, especially the outer surfaces. The outer surfaces of the workpiece of a cylindrical job can be removed, okay, as per the required size and dimension and surface finish. The main objective of a turning is to reduce the workpiece diameter to the desired dimension. This is very, very important. What is the main objective? The main objective or the main aim of any turning operation is to reduce the diameter. That means, suppose if the diameter of the workpiece is say 25 millimeters, so we have to reduce to 20, then I have to remove the diameter from 25 millimeters to 20 millimeters by giving a certain depth of cut at every step. So the main objective is to reduce the diameter from larger to smaller. There are two types of turning operations. One is called as a rough and finish. Of course, that depends. So now in turning operation also, the main objective is to reduce the larger diameter to smaller diameter. But when we reduce this, what are the different types? Rough turning and finish turning. Okay, rough turning operation aims to machine a piece to within a predefined thickness by removing the maximum amount of material in the shortest possible time, disregarding the accuracy and surface finish. See, what we do is a very simple understanding. In case of a rough turning, we give more depth of cut and we are not bothered about the surface finish, the dimensions, because why we are going to give depth of cut at the beginning more, because if at all I want to reduce, to take again the same example, from 25 to 20 millimeters, I have to reduce it to 5 millimeters. So directly at the beginning I can go directly for 2 millimeters. So if I go for a 3 millimeters total depth of cut, okay, then what happens? You are going to reduce from 25 to 23. Then I can adopt the next type, that is called as a finish turning. Finish turning produces a smooth surface finish and the workpiece with final accurate dimensions. So whenever that means, to give a simple example, from 25 millimeters to first I can reduce to 22, then from 22 to 21, from 21 to 20. When I am going to reduce from 22 to 21 and 21 to 20, I can go for the finish turning process. This is the meaning of the concept of rough and finish turning. Because when we go deeper, that means when we are going to reduce, when we are going to touch the final dimension to 20 millimeters, then the depth of cut which we are going to give is less compared to at the beginning of the operation. Different sections of the turned parts may have different outer dimensions. Means different sections means what? Different parts of a workpiece can have different outer surface dimensions. The transition between the surfaces with two different diameters can have several topological features, namely step, taper, chamfer and contour. So what he wants to say is, we are not going to reduce directly from 25 to 20 millimeter the entire length. In some cases you may have steps, in some portion it may be having a taper like this, but all these are coming under the classification of a turning only, like step, taper, chamfer and contour, which we are going to discuss in the subsequent slides. To produce these features, multiple passes at a small radial depth of cut may be necessary. That means whenever I want to go for reduction of a diameter, I require to give a stepwise depth of cut. Now let us have an understanding in detail about the step turning, which is the first type of a turning operation. In a step turning, as you are going to see very clearly on the screen, there is a step which you are going to see here. See, there is a step here. This is called as a step. Okay, so step turning creates two surfaces with an abrupt change in diameters between them. The final feature resembles a step. So why we are going to call it as a step? The reason is very simple again. We are not much bothered about the actual holding will be like this. This is a chuck holding which we have not shown here. It will come like this. This is a headstock chuck which is there, and this is made to rotate, as you are going to see very clearly. And here we are going to give the depth of cut is given like this, and this is the feed rate which is given continuously to reduce the diameter from larger to smaller, and whatever the length of the workpiece is there, that is also shown here clearly, as you are going to see here. So that means you are going to see here one minute, I will just adjust the recording now. Okay, now as you are going to see very clearly on a sketch here, so this is called as a single point cutting tool, which you are going to see there. Then you will be having a feed direction, which you are also going to see. This is called as a feed direction, and this is the length of the step which we are going to create. That means we are going to reduce from, as you are going to see clearly on the screen, we are going to reduce from the diameter D1 to D2. So when we are going to reduce the diameter from D1 to D2, there is no need that we have to give the difference of depth, whatever is there, very high. Okay, so we can reduce from D1 to D2 in a stepwise, not at a time. That means the initial diameter, suppose if D1 is equal to 25 and D2 is equal to 20, we are not reducing from 25 to 20 at a stretch by giving a certain depth of cut. So we require to go stepwise, but finally what we are going to do, we are going to produce the step which you are going to see on the screen here. This is the step just I have explained. Okay, the final feature after machining operation, you are going to observe the step surface. That is important. So the next type coming up is taper turning. So all these are coming under the types of a turning only. Just I have told about that. So taper turning produces a ramp transition. This is called as a ramp, means as you are going to see, the ramp means what? There is a tapering process. That means it starts from this point and ends at this point. So this portion, whatever you are going to see now, this is called as a taper. Taper turning produces a ramp transition between the two surfaces with different diameters due to the angled motion between the workpiece and a cutting tool. Now you are going to see very clearly, very interestingly, the cutting tool has to move in this way. Try to understand that. Okay, it has to go at a certain angle, as you are going to see. This is, suppose if this is the axis, at certain angle it has to move. The feed rate is shown like this, but actual movement will be like this only, and the workpiece is rotated, and to the required length the tapering operation can be carried out. What is the main objective of a taper turning? It reduces from larger diameter to smaller diameter, but whatever the surface is there, that is having a certain type of a slope, which you are going to see very clearly on the screen. So such a operation we are going to call it as a taper turning. So the next one is called as a chamfer turning. Chamfer turning. So chamfer turning, if you have a keen observation, especially in the case of your bolts ends, okay, or ends of the different types of screws, whatever is there, this particular operation will be done, which you are going to see on the screen. I wanted to make it slightly larger here. Just observe it. So now you are going to see a very small taper, like, which is shown as small w there. It is shown as a small w there. Okay, so that is the width of that chamfer, and again you are going to see the D1 is the initial diameter and D2 is the final diameter, but this chamfer is just going to work like a taper turning, which we have discussed in the previous slide. The same operation, but only thing is the length of the taper is very, very less. So that is why it is called as a chamfer, and it is always at the ends of the workpieces. Whatever the workpiece end is there, at the end only it is being created, as you are going to see on a sketch. It is similar to step turning. Chamfer turning creates angle transition of an otherwise square edges between two surfaces with different turned diameters. The same explanation is shown. It is going to work like a step turning only, okay, because whatever the amount of taper is there, that is very, very less. That is why it is called as a chamfer turning. Always it is given at the ends of the workpieces. The next one coming is called as a contour turning, CONTOUR. So as you are going to see, contour turning operation, the cutting tool axially follows the path with a predefined geometry. That means we require to follow, you see the shape of that. See, this is called as a contour turning. So contour means curve type. So the tool has to be moved in this way with certain type of an indexing, what you can say. Okay, so that is how we require to form the contour turning. Multiple passes of a contouring tool are necessary to create desired contours in the workpiece. However, form tools can produce the same contour shape in a single pass. So there are two methods. Actually, we require to use, we have to take the help of a single point cutting tool and form like this. This is one process, and another process which we are going to discuss while doing the forming operation in the subsequent slides. Okay, so now we shall have a discussion. So now we have discussed about the four types of turning, major types, that is step turning, then the next one is a taper turning, chamfering, and the contour turning. All these are coming under the main process of turning only. Now whatever the operations which we are going to discuss, there are other operations rather than a turning. So the first one is called as a facing. So as the name itself indicates, face means what? Front portion of the workpiece. So observe the front portion of the workpiece here. Whenever the workpiece is always a cylindrical type, here your headstock chuck will come, and this is called as the end of a workpiece, end surface. Though this end surface has to be machined. So when the machining of this is done, I am going to give a very, very small depth of cut, and then I am going to cut the workpiece. So in facing operation is always used for the purpose of reducing the length. Try to understand why facing operation is done. Facing operation is done in order to reduce the length, but whereas the turning operation is carried out to reduce the diameter from large diameter to small diameter. Turning operation from large length to small length, then we can go for the facing operations. That is important. During the machining, the length of the workpiece is slightly longer than the final part should be. Okay, facing is the operation of machining the end of a workpiece. Actually, the machining is carried out at the ends, just I have explained, that is perpendicular to the rotating axis. So whatever the surface is there, okay, the feeding is done in this way in order to give a finish to the end of a workpiece. During the facing, the tool moves along the radius of the workpiece. As see clearly there, it is moving along the radius of the workpiece to produce the desired part length and a smooth face surface by removing a thin layer of material. So it can remove very thin layer of material, because whatever the depth of cut which we are going to give is very less compared to the regular turning operations. So the next one coming up is called as a grooving operation. Grooving. Grooving means what? We require to give at different locations of a workpiece a very small diameter. Grooving is a turning operation that creates a narrow cut. You are going to see a narrow cut here. This is called as a narrow cut. Very small cut is there at the certain position of a workpiece. A groove, this is called as a groove of width W, which you are going to see. And that groove width is just similar to the width of the turning tool that is used. Whatever that width is there, the same one is, you are going to get the same width. Grooving is a turning operation that creates a narrow cut, a groove in the workpiece. The size of the cut depends on the width of a cutting tool, width W, which you are going to see, which is the groove that is created. The same width even the single point cutting tool should have. Multiple tool passes are necessary to machine wider grooves. Suppose if at all I want to go for more than the width W, then I can have multiple passes to make the groove larger. That depends. There are two types of grooving operations, external and face grooving. There are two types of groovings are there. One is called as an external grooving. So whatever I have shown, this is called as an external grooving. A tool moves radially into the side of the work piece and removes the material along the cutting direction. So what we are going to do, the feeding direction is directly like this only. Depending upon the width, I am going to generate the groove. That is called as a groove. In face grooving, the tool machines groove in the face of the workpiece. Suppose if I want to carry out on this surface, also I can do the same operation in the face portion of the workpiece. Okay, that is called as a grooving. But the most commonly used definition is what? This one only. Depending upon the width of the workpiece, it is possible to produce a certain width groove on a surface of a workpiece. The next one coming up is parting operation, or sometimes it is also called as a parting off operation. So in a parting is a machining operation that results in a part cut off at the end of the machining cycle. So parting is an operation of as good as the cutting the workpiece itself into parts. That is the main function here. So what we do, suppose a very larger length we don't require. So I don't require this much amount of length. Directly what we are going to do, we are going to rotate the workpiece. Then I am going to feed the cutting tool. Then I am going to remove this portion. Okay. So such a operation is called as what? Parting off operation. That is why parting is a machining operation that results in a part cutoff. Part cutoff means what? Certain length of the workpiece I want to cut at the end of the machining cycle. At the end of means at the last phase of the cycle. The process uses a tool with a specific shape to enter the workpiece perpendicular to the rotating axis. As you are going to see very clearly, it is fed exactly perpendicular to the workpiece axis, and make a progressive cut while the workpiece rotates. This is important. It is just like a grooving only. In grooving, what happens? We are going to keep some material. We are going to keep some material at any portion. Okay, that is called as a grooving, but whereas of the workpiece. But whereas in case of a parting, we want to remove completely this portion. So what we do, we are going to feed the workpiece directly and we cut and take out that part. After the edge of the cutting tool reaches the center of the workpiece drops off. That is what he is telling. Once the cutting tool reaches the center of the workpiece, it will automatically fall down. A part catcher is often used to catch the removed part. Whatever the portion of the part being cut, it is being held by a certain supporting device that is called as a part catcher, which is kept in your on a lathe bed or whatever is there. But you have to understand that parting or a parting off is an operation of cutting the workpiece itself into parts. That is very especially at the ends of the workpieces. The next one operation is called as a threading. So this is a very common example which you are going to see especially on your screws and the bolt surfaces, etc. So whenever if you have got a clear observation of all these devices which are used as joining devices, they are called the joining devices, okay, or joining elements what we call. So in such joining devices, what you are going to see, you are going to see the threads as you are going to see clearly on the screen here. So you have to understand what is the meaning of a pitch. This is called as a pitch. So pitch is called as a successive difference between the two crests or two crests of a threaded portion, and this is called as a length which is being cut here. And whatever the type of thread is there that is to be generated on the workpiece, it is shown there, but it requires to control the feed of the cutting tool. That is why the cutting operation, especially the thread cutting operation, is carried out by engaging the carriage with the tumbler gears which are provided at the back side of the headstock. That again we are discussing in detail, but now we need to understand what is the meaning of a thread cutting or threading operation. Threading is a turning operation. Actually threading is also coming under a turning operation. Basically we are going to take the help of a turning of a workpiece, then we produce that profile in which a tool moves along the side of the workpiece cutting threads in the outer surface. Threading here we are going to cut on the outer surface. A thread is a uniform helical groove of specified length and pitch. So that is very important. You are going to see the length on the screen. You are going to see the specified length on the screen. You are also going to see clearly the pitch. Okay. So, and also you are going to see what is the formation of this. This is called as a formation that is provided directly on the cutting tool end itself. Deeper threads need multiple passes of a tool. So what we do, if the depth of thread is more, then we require to pass the cutting tool for more number of times. But we need to understand that what is the definition? A thread cutting is a uniform helical groove of specified length and pitch which is formed on the surface of a workpiece. Now we require to understand about the knurling. Knurling. Knurling is the operation that produces serrated patterns on the surface of a part. So this is a very common practical example. So whenever you are going to see any type of, I think you have already used, okay, in your MT and QC lab, whenever you are going to operate your vernier scales or micrometer, you are going to see that screw is there which is used for adjusting the diameters. It is having a certain pattern on its surface, practically to tell you, which already done. So if you are going to have an observation, I am slightly making it bigger. It is very interesting to know that this surface is called as a grooving. So it's a certain pattern that is created on a surface. This is also called as a grooving, which you are going to see. This is also called as a knurling, and this is also called as a knurling operation. This is nothing but a pattern that is provided on the surface of a workpiece. That is, so in order to give grip to the surface, otherwise it slips whenever we want to operate, especially the sophisticated types of measuring instruments. Knurling operation produces serrated patterns on the surface of a part. Knurling increases the gripping friction and the visual outlook of the machined part. Even it can give a very wonderful look on its surface, as well as it is also going to provide the gripping facility. That is the main advantage of this. This machining process utilizes a unique tool that consists of a single or multiple cylindrical wheels or knurls. So whatever the cutting tool is there, that is called as a knurl. It is already having a pattern on it, just it is pressed against the rotating workpiece, which can rotate inside the tool holders. So as you are going to see very clearly, this is nothing but the knurled tool, and now it is creating a pattern here. It has created a pattern surface like this. This is called as a knurled tool, and this is the workpiece, okay, on which the knurling operation is already being carried out, as you are going to see. So what we are going to do here, the knurls contain teeth that are rolled against the surface of the workpiece to form serrated patterns. The most common knurling pattern is called as a diamond pattern. Diamond pattern is the most commonly used type of pattern on the outer surface to provide a certain amount of a grip on its surface. This is very, very important. The main objective of this is to provide the gripping surface, and whatever the pattern is there, it is called as a diamond pattern, because the knurled cutting tool is having the teeth of that particular pattern, which is held in a knurling holder, and it is pressed against the rotating workpiece. So as it is pressed, that pattern is directly obtained or produced on the surface of a workpiece. That is the main operation of a knurling. So now let us have an understanding about the drilling operation. So this is definitely drilling is a different operation, because as you know very well, drilling is basically, when we define drilling, it is an operation of producing a hole, a simple definition of a drilling. So whenever we want to carry out the drilling operation, it is on a lathe machine, it is necessary to hold the twist drills directly into the tailstock spindle, okay, and it is pressed against the rotating workpiece, which is held in a headstock chuck. Drilling operation removes the material from the workpiece inside of a workpiece. Whenever, it is a very simple thing. In case of a regular turning operation, what we do, we remove the material from the outer surface. But in case of a drilling, we remove the material of the inside surface. Okay, inside we are going to produce certain diameter hole by the process by using the twist drill. The result of drilling is a hole with a diameter equal to the size of the utilized drill bit. So whatever you are going to see on the screen, again I am going to make it slightly larger. So this portion is held on a headstock chuck. It is made to rotate, and the feeding direction is done like this. Here your tailstock spindle will come, and it is going to be fed against the rotating workpiece. So whatever this portion, whatever this is called as a twist drill, as you are going to see here, this is called as a twist drill only, which is used, which is firmly held in a tailstock spindle and pressed against the rotating workpiece. Drill bits are usually positioned either on a tailstock or a lathe tool holder. Of course, lathe tool holder is also another one, but the most commonly used in this particular type of process, we are going to hold that drill bit in a tailstock, as he has already explained. The next type coming is enlarging the hole. Not enlarging. We want to go immediately after drilling. Generally, we go for the operation called as a reaming. So reaming is nothing but what? The operation of giving a fine finish to the previously drilled hole. This reaming operation is always carried out after the drilling. We cannot carry out the drilling operation, we cannot carry out the reaming operation directly like a drilling. First I have to drill, okay, at a to a certain length in a workpiece, then I have to carry out the operation of a reaming, but the operation is just similar to what we have discussed for the drilling. The type of cutting tool which we are going to use, that is called as a reamer. That reamer tool is fixed in a tailstock spindle as usual, and again it is fed against the rotating workpiece, how we have discussed in the drilling operation. Now I will read out. Reaming is a sizing operation that enlarges the whole of the workpiece. Actually it is called as a, it is going to enlarge means what? Actually in reality it is going to remove very less amount of material to give a fine finish on its internal surface. In a reaming operation, the reamer enters the workpiece axially through the end and expands an existing hole to the diameter of the tool. Of course it expands, it provides slight expansion, not a major expansion of the previously drilled hole. Reaming removes a minimal amount of material. That is what he is telling here. Minimal means what? Very minimum, and is often performed after drilling. Just I have told, to obtain both a more accurate diameter and a smoother internal finish. The main objective here of a reaming is to give a fine finish to the previously drilled hole. That is the main objective of a reaming operation. The all other process of carrying out remains same, just like a drilling only. So now in boring, now we are coming to the boring operation. So boring operation is generally carried out after the drilling operation when we want to go for the larger diameter hole is produced. A larger diameter hole is produced, then we call it as a drilling. In boring operation, a tool enters a workpiece axially, as you are going to see the feed direction, and removes the material along the internal surface to either create different shapes or to enlarge an existing hole. To create a different shapes means what? Different internal steps cutting can also be done. Internal step cutting can also be done, or even to enlarge the existing hole which is previously carried out by the drilling operation. So such a operation we call it as a boring operation. So remember, boring operation is nothing but production of a slightly larger hole than the drilled hole. That is the main. And we are coming to the last concept, that is called as a tapping. It is exactly opposite to the thread cutting. In thread cutting operation, we are going to provide the production of threads on the external surface of a cylindrical workpieces, but in case of a tapping, it is we are going to produce the internal threads. That means when the whole drilling is done, if at all I want to go for the production of internal threads, then we call it as a tapping. Tapping is a process in which a tapping tool enters the workpiece. So this tapping tool, whatever you are going to see here on the screen very clearly, this tapping tool so this is called as a tapping tool. He has shown already entered inside like this. Feed, this is a feed direction. So as usual the workpiece is rotated, and whatever the tool is used, that is called as a tap. And remember, the tool is rotated in this direction. Already the direction is also shown there. See clearly, okay, the direction of rotation, and also it is given a feeding at the same time. So as it is fed, there is a production of internal thread cutting on a previously drilled hole. Okay, that operation we call it as a tapping. Tapping is process in which a tapping tool enters the workpiece axially and cuts the threads into an existing hole. Already the hole should be there. In that, the internal threads can be cut. The hole matches a corresponding bit size that can accommodate the desired tapping tool. It is necessary to decide the tapping tool diameter depending upon the previously drilled hole. That is very important. Tapping is also the operation used to make a thread on nuts. Even the whatever the thread cutting operation on nuts is there, even that can be carried out, because you are going to see on a nut it's having internal threads. Okay, even those production can also be done by using the tapping tool. So this is called as what? The tapping operation. Okay, and whatever the pitch of the thread that is being cut, that depends upon the size of the tap, the dimension, its specifications. Based on that only the tapping that is being produced, or internal threads being produced, can have the same profile which are already present on a tap. That is the main concept here. Okay, so this is called as a tapping operation. I think that completes the whole of the today's session. And along with this, I have also joined one of the important lathe machine operations videos. You just go through that, so for better understanding. Okay, thank you.
Raw material 32 diameter, length 115 mm length. Okay, it's a my stick. First of all, hold the raw material. Self-centering Fijo chuck. It's a chakki. This is a chakki. Next, say knife edge tool, right hand side. Say right to left जाएगा उसे right hand side knife edge tool. Say adjustable tool post. अभी centering adjustment. Tail stop के center में. So center adjustment. So adjustable tool post. The centering. So first operation. So light cross में कर दो. First operation is a facing. तो RPM रहेगा इससे 250 RPM. Generally facing operation and turning operation is 250 RPM. इसे forward switch. So forward switch. इसे 250 RPM C और E. Okay, so by यानी right to left. Centering. It's a revolving center. It's a combination center drill. It's a standard more step for MT4. It's a push. Say tail stop clamping. Say tail stop clamp. And second side is a facing Second side is a total length is a placement and centering. Okay, so 15 mm length. So 15 mm. Okay. Next is a hole turning 24 diameter. 110 total length. So one side facing, second side facing, and centering. Okay. Say 24 diameter is a hole. The chuck and 2 between center. Rolling device is a live center and dead center, 2 between center. Okay, and start turning, plate turning operation. 10 mm marking and start to 1 mm, 10 division is a plate turning. We must mix the So stepped on fiber. Step 90 mm length. So stepped on it. Next operation is a taper turning 10 degree. Zero, right hand side is a 10 degree. 10 degree. So taper is 10 degree of. Tool setting. outside diameter, so measure 25. Okay, and 4 measure vernier caliper. Next operation is a square tool. Square tool. Knife edge tool. Knife edge tool. First our facing. So facing, plane turning, step turning, 1, 2 and 3 is a step turning and taper turning, knife edge tool. Next tool is a square tool, square grooving या parting off. So approach angle 90. It's a compound slide, so straight. So 0 0 setting. Next tool is a form. It's a square groovy. Next tool is a form tool. It's a form turning. Radius tool. It's a concave and convex. concave and convex. Next tool is a V tool. It's a chamfering and threading. It's a V tool. Chamfering operations and threading operations. And threading operation. 2 mm each. 2 mm gear chain number 1. 2 mm each. HJL. यानी RPM, slow RPM, threading RPM, slow. X यानी right hand side. Gear chain number 2 mm each. Start. Touch. Then 0. Half touch catching. Start. Stop. Reverse. It's a threading operation. First cut, say rough and fine cut. It's a 3 division, 2 division, cross line. Maximum 20 division, 1.75 mm. Fine cut. Stop. Threading operation. It's a V-shaped thread. Next operation is a knurling operation. It's a knurling operation. It's a knurling operation. Medium cross knurling, यानी diamond shaped knurling.